Okay, question number 6. An object of mass m is sliding along a ramp at a constant speed. That means the object, let us say if it was here, its velocity was still v only, here also it's v, here also is v. Okay, v, which means kinetic energy is not changing. During the motion, it travels a distance x along the ramp through a vertical distance h. Okay, h is the distance traveled here. Coefficient of dynamic friction between the ramp and the object is mu. Okay, it's mu here. What's the total energy transferred into thermal energy when the object travels a distance x? Right. Okay. So usually what happens is potential energy gets converted into kinetic energy. But here you see kinetic energy is almost is the same, right? So here let us write down the equations, energy equations here, conservation of energy. So here it will be half mv square minus mg. Let me call this value as some L over here. It has dropped by a distance L, so I can write minus mgl. Okay, and then some work has been done against friction, so I'll write W1 over here. Now if you write the equations here, the equations here will be once again half mv square minus mg into, now what is this now? This should be L plus h, and then there's a work done by it which is W2 over here. Okay, I'm not revealing, I do not know what's the value of W1, W2. Of course you can write it down, but I'm not writing so much. Now this should be equal to this, right? Energy is being conserved, energy is not being lost anywhere, right? So therefore if I equate them, then what will happen? Minus, I'll write half mv square minus mgl plus w1 is equal to half mv square minus mg into L plus h plus w2, right? So now this half mv square, this half mv square goes away. Now what is left behind over here? You have minus mg into L plus h. I'll push this one this side. Okay, when I do that, what will happen? I get mg into L plus h minus mgl is equal to w2 minus w1. What is w2 minus w1? The work done by the friction, okay, when the object starts from here and reaches here, minus the work done by the friction along this one, which means there is a net work done by this one, okay, or net energy received by the friction. Or this also you can say, what does friction do? Friction produces heat energy. So you can say this should be equal to the heat energy produced, right? And now if I simplify this one, what will happen? mg into L plus h minus mgl, this should now be equal to mgh. Thus the heat energy produced is equal to mgh, right? So option is E. Okay, let us move on to the next one.